Okay, we are live.
Right, cool.
All right, well, if you're ready, then I say we get started.
Do you want to jump right in the quiz?
I think so. I mean, for the homework, nothing seemed too crazy.
Yeah.
So, it seemed a lot of the same, some of the math, just using different, data and stuff like that. So.
Yeah, and a lot of the questions are like, based off of this, would you reject or,
Right.
or fail to reject? And it's like, oh, we've been doing that for a couple weeks. So.
Yeah, I agree.
Well, I loaded mine up here.
Okay.
18 questions.
18, huh? Wow. Okay, so.
Okay, got to get the book up because I always forget. But
Yeah.
The first question seems like one of the ones that we'll answer with the book, but
directly out of the book, yeah.
And the second one, for that matter. Well, I guess the fourth one technically, but.
Yeah. So. Okay, I got it up. The normal probability applet up. The data files will be when I need them. Okay, so are you ready?
Yeah, I am.
Okay, so I'll read question 3. In a ANOVA hypothesis test, we reject when there's sufficient evidence to indicate at least one mean is different from the others. So that would be true, right? Because as long as we would reject it, if there's enough evidence to indicate at least one is different than the others, because the null is all are equal.
Yeah.
Right.
So the alternative hypothesis is that one or more of the means differs from the other.
Yep. So
I think that was probably one of the ones I missed in my homework, but yeah, that makes sense.
Okay.
Just a matter of looking in the book, which is available to us all the time. So.
Yeah.
Okay. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. The requirements of ANOVA, there's 2 of them. Does it say something about the data are normally distributed in each group?
Data in each group, yeah, that's the second one.
Okay, and then the variances are equal for each group?
And the third one.
Okay, I don't think it says anything about sample means being positive. There's just 2 bullet points under the 2 requirements. Well, yeah, 2 requirements. Okay, that's it.
Oh, okay, cool.
Just got to read the words. I didn't do that, but.
Oh, you're fine. All right, so question 5. To check if each group is normally distributed, do the following. Construct a scatter plot, construct a histogram, or construct a QQ plot. So it's the bottom one, right?
Yeah, it's a QQ plot. So it says the data are normally distributed in each group, and then under it says we check this by creating a QQ plot for each group separately.
Yep.
I mean, we're cruising right now.
Yep.
We assume the variance in each group is the same if the following happens. Okay.
So if we look at 3.2, it talks about the variance, and it says the requirement is checked by examining the variances. The rule we will use is if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Okay, so if the largest variance is less than or equal to, there's
4
one that says
times,
the
right?
largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the sample mean.
Yeah, that's not. I think
I
it's
mean,
got to be that second one, but
it says that less than or equal to, though, right?
if the largest variance is less than or equal to 4 times the smallest variance, yeah.
Well, I mean, I'm willing to go with that one, and if we miss it, then we'll figure it out. But I think that's the
Right.
closest one to the answer. What do you think?
I think so too. I don't like the way it's worded, but I mean, it makes sense based on what they, the variance question here. Yeah, I'm good with it. We can see what it says.
Okay.
All right. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
So you would just do 4, 1, which would be another one. 4, 2, which is another one, and 4, 3. So 3 more, so it'll be 6, right?
3 pairs are 3 pairs. Yeah, I think you're right. You got 3. Well, hold on. Or is it 12? Because if you have 1, 2, 1, 3. Oh, wait a minute. Hold on.
Those are all pairs. So
No. Yeah, sorry. Yeah, you're right. So 4.
4, 1, 4, 2, 4, 3 added to the 3 that there already are.
So 3 more pairs. 6 total. Right. Sorry.
There's always one way to find out is if we press the submit button at the bottom, but that's what I think it is.
Yeah, I think you're right.
I've been doing a lot of GRE studying for the graduate test, and so I'm like really used to trying to think outside the box here. So see if it pays off for us.
Cool. Yeah. That sounds good for me.
Not that that's thinking outside the box. It's actually fairly simple, but oh well. All right. So the funny thing that I noticed about this is that they don't put them in 3 separate columns. They just put like the category, and then it changes to the second category, and then the third category, and the fourth category, fifth, and so on, if that makes sense. So there's like multiple things. So it's like A, and then B, and then C, and then D.
Oh, all on a line. Yeah, I see what you're saying.
So it looks weird. It looks different than what we've been used to, but
yeah, I always wonder, are they trying to trick me there? Are they purposely doing stuff different
yeah, I don't know.
to confuse me? I mean, I'm easily confused already. I don't need any.
So I guess what I did on the homework was I just copied the different letters. So like where it says A, just copied all that data, B, and then so on.
Right. That's exactly what I was just doing right now.
And then just posting it in this variance thing. Variable thing, excuse me.
So it's socks, another one?
I think
so. Oh, must be the last set.
I think it's different types of shoes, and then it's like if you play in your socks or something like that. We'll have to read the problem and make sure that we're doing it right.
Cool.
Seems to be another category.
Yeah, it says there's 6 groups. So what is the minimum or smallest variance for the 6 groups? So yeah, definitely 6.
Is that the question?
Yeah.
Oh, so it's 27.208 is the minimum. variable 3, I think, is what it is. You see that?
Let's see, variable variances. Yep, that's the smallest, 27.208.
What is the maximum? Should be 53. Is that? Yeah, that's right.
Yeah, 53,158. Is that what you got?
Huh? Okay, the test for equal variances is satisfied for this data.
So
So
the
isn't
test
that,
is, that's the, if S is, if the largest standard deviation is less than 2 times the smallest, right?
I think it's 4 times the smallest. Remember you read that? It was the 4 times is either greater, less than or equal to 4 times the smallest.
But that was
Is that a different thing?
for variances, yeah. Because we're determining now I remember this from the lecture. Hold on, let me see if I can find it.
Doesn't it say the test for equal variances is satisfied? So is that what we did in the other question, or?
No,
thinking-
oh, wait a minute. Hold on. Sorry, I'm reading 3 things at once. Test for equal variance. Oh,
Yeah,
yeah.
question 6, it says we assume the variance in each group is the same if the following happens and it's the largest variance is less than 4 times the smallest.
Yeah.
So I'd say
So-
true, right?
Yeah, because the largest variance is definitely. Yeah, because it's definitely less than 4 times the smallest, that's for sure. So yeah, I agree. So true. Construct. Oh, we gotta do QQ plots for each of these. You know what we could do? If you take the first 3, I'll take the last 3. That might save us some time.
And aren't they're supposed to be right skewed, isn't that right? So they're normal if they're right skewed?
Well, if you're doing a QQ plot, it just needs to be, equal top and bottom, but you gotta sort the data to make sure it's smallest to largest. Does that make sense? Yeah, see, if I just did number 1 just to see, and it looks good.
Did you plug it into a different spreadsheet?
Yeah, you gotta open that other
Sorry.
spreadsheet. No, you're okay. I can have this done in just a second. I can just click the right button. Yeah, see, the 6th one looks good. The first one looks good. Boy, that 5th one looks a little, it's close on that 5th one. I think overall it's generally good.
Yeah, it says the question says approximately normal, so
Yeah.
it doesn't have to be perfect, but
So it looks like they're all pretty close. I mean, there's nothing with any huge thing that makes me question it. There's a couple that I go, but overall, I think they're in good shape, to be honest with you.
okay. We always have the 50-50 rule on this
Yeah,
one.
on this
So.
one. I just hate to miss this one because, should be simple, but.
It's true. Oh, did you ever see the email that Brother Bennett sent us?
Yeah, I just saw it today. I'd emailed you, and I hadn't even, like I said, I didn't do anything yesterday, and so I looked at it today and went, "Oh crap!"
Yeah, we just did it
like
backwards.
Yeah, because a negative minus a negative is going to be a positive. So we just did the math backwards.
Yeah, but I am happy that we missed it on our homework because it doesn't, or on our quiz because it doesn't really change our grade. But this later this week on the test, it's going to change our grade if we mess that
Oh
up.
yeah. Oh yeah. I agree.
Got to be sure that we get it. Okay, so question 12 says perform an ANOVA test in Excel. That's what we have, and
Right.
observe that the p-value is 0.081, which is what we have, which means we're in good shape because we have the data in right. Then remove the SOX data and perform the text again, the test again. What is the p-value when the SOX are removed? SOX data is removed.
We
So we
removed
just
the
delete
SOX.
variable 6, right?
Yep. That was the SOX. So 0.309. What you got?
Yep. Yes, sir.
What's up, everybody?
Hey,
What's going on,
Michael.
Sorry I'm a little late. Work, whatevs.
No worries, man. This one seems to be going pretty quick. Now that I've said it, I'm gonna jinx us here, but
Oh no, what have you done?
yeah.
What question are we on by now? I'm just pulling up the quiz now.
We're on 13.
Holy crow. Well, okay. I'll just hang in there.
We'll go back and work with you through it. It's not a big deal. What we might do is submit. That way we can figure out which ones we did wrong, and then you have a full submit before we have to do any worrying.
Yeah, we also, this is the last question on this with this data, so we can start with us on 14 and go through 18, and then we can go back and figure it out after we turn it in.
Sure, totally.
So Eric, I think the test statistic for an ANOVA, the p-value is the area on the right, I believe. Because if you just type in p-value on like Control F on your book, there's like a right skewed like bell curve thing, and it says p-value, and there's an arrow pointing to the right side of the thing. I don't know if you see that, but it's under step 4 of.
Oh yeah, 3.1. Is that what you're looking at?
Yeah, that's probably it too. I don't know. I'm not looking at that one, but
yeah,
that's what it is. I see it there too. So.
Yep, that works for me.
Yeah, it's the right. Okay. Yeah. Better, anyways. That's a way better answer than I had. I was just guessing at that point, but you found the right data, so we're good.
All right, so now we'll do 14. These spreadsheets make this so easy.
Yeah.
Which spreadsheet are we using this time?
The one we used last time is just another sheet at the bottom that says ANOVA.
Oh, neat.
Okay, so this one's kind of, you make sure we read the directions on this one.
I don't like the way they set these spreadsheets up with it. Oh, because there's calories and sodium. I see what you mean.
Yeah, which means we need to read the directions, because if we don't, then we'll. Michael, did you see that email that that our teacher sent us about how we just did the data backwards, and so we missed the problems?
Yeah, we flipped the positive for a negative, and had we plugged it in the other way, we would have had it.
Yeah.
That's why I'm like looking at this very intensely to figure out how we're going to do this.
Did you see his last disappointing email that nobody shows up for office hours, and that if we would all just watch the videos, our lives would be a lot easier?
I saw the one last week.
Yeah.
I mean, I've seen those emails, but I mean, if he doesn't post a video for us to watch because nobody goes, then I don't know.
Yeah.
Apparently he still makes a video and just covers a couple things based on questions that he's either gotten email or what he feels is best. And I don't really know how it all works. And I guess I shouldn't say too much because I don't understand it all. But it was just interesting. I felt scolded for not showing up to office hours.
Well, another thing is it's in the middle of the day, and I mean, I have work, and
Yeah.
you guys, I assume, have work, and everybody has things going on right in the middle of the day. Nobody can
Yeah.
dip out for lunch just because it's available for him. But
Yeah, I work overnight, and being awake at this time of day is one of the most inconvenient things in my whole life.
Sure it is. All right.
It
So
doesn't.
oh, sorry. Go ahead.
No, go for it. Go for it.
I was just going to say, so according to the question, they want us to look at the calories first, but they want us to construct QQ plots. So it's that other spreadsheet, the second one, or the first one, depending how you look at it. So the first set of data looks good. It looks nice and even. Second one looks good too.
So we're throwing this in there, each variable by category, like beef or poultry.
Well, that's what I did first, and then I realized it was asking for a QQ plot. So I'm actually dropping the same data in the quantitative descriptive statistics spreadsheet, and it just does it for me. And they all look good, but yes, I have them in the other one too, in the individual variable slots. Because it says, let's examine the calories first, construct QQ plots of the calories for each of the 3 types of hot dogs, and compare the variance to determine if the assumptions to use ANOVA have been met. So they look good. They're normally distributed on the QQ plot, so it's definitely the top one, I think, looking at this stuff.
well, let's go with that one then.
I wouldn't think they'd give us data that would they want us to use and then not give us the good stuff, you know?
Well, we always have Michael's turn in, so
Oh, yeah. So we can test it and then see. Yeah.
so the top
Okay.
one is what we're going with.
Yeah, because, I mean, the assumption is that they're normally distributed, and the QQ plot, shows about the same above the line as below the line. So on all 3. So it looks good.
All right. So 14 is A. The assumptions have been met. Yeah.
Yeah.
Well, if they give us all the information, do we have to actually run the test?
I was just looking at that going, jeepers, you guys gave us everything.
Significance level is 0, right? So what is it if the p is low, reject the null or something like that?
Mhm. Yeah.
So we should have sufficient evidence. This is the calories, right?
Yeah, this is, I think it's calories. Yeah, it's still for the calories. Yep. So it should be.
Should be C, right?
Yeah.
Yeah, we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories.
So that's super weird because the ANOVA test, throwing that data into variables 1 through 6, segmented sodium and weight. Oh, if we're
Yeah.
only testing calories, taking out
Yeah.
sodium, that makes sense.
Yeah.
I was like, these numbers don't line up.
Yeah. Just do the first half. I know I did that too and was like, what is going on here? And then
Yeah.
they want the sodium in the second half, question 16.
Okay.
So So let me drop these in this QQ plot and see what they look like.
When you do, you'll apparently observe that there could be a problem with normality.
These questions have been very helpful today.
Yeah, that first one's a touch different. I wouldn't call it horrible, but second set definitely looks good. I mean, nothing looks too crazy. I mean, they all look fairly close.
We're looking at poultry, right? The poultry one is the one that suggests a possible problem.
Which one's the poultry at the bottom? Yeah, that's the one I'm looking at right now, and I mean, it's definitely. I mean, it's not that out of whack. I mean, there's quite a bit. I don't know. Can I share? How do you share a screen? I'll show you what I'm looking at.
There should be a green button with a white arrow on the left edge of the Hangouts.
Oh, screen share. Can you guys see that?
Yeah.
Does that look crazy to you guys?
It tells us in the question that our observation should be that once we do this, we see that there potentially could be a problem with normality, and the smallest variance being 7180.75, the largest being 10,492.871. It's just a question of, is that outlier so outlying that we can't consider this normally distributed anymore?
I don't know. To me, it doesn't look like it's too far outlying. I mean, it's a little bit, but
Yeah. If we're going with the side that says that it still looks normally distributed, it's still good, then the assumptions would be met. And yeah, while it's safe to assume each group comes from a normally distributed population, no. Shoot, that's tricky. Yeah. If we're saying that the assumptions have been met, then there's only one option.
well, see, the interesting thing is it asks the next question, right? It asks for the p-value and all that. So I think we're okay to assume that they've been met. I don't know. Thoughts?
Let's roll with it. Let's see.
Yeah, I'm good with that. I've just been thinking over here. I think you're right. Let's just roll with it because we
Okay.
always have another turn in if we need to.
Yeah, because I can go first, and then we can see what it does, and then we can go from there.
I'll try the second one, and then
Okay.
if that's wrong, and then Michael can try the third one, and then by that time we'll know it's the fourth one.
Right. That works for me. All right, so question 17. Does the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups? What is the p-value for this data?
Oops.
So 0.179. So you guys got
Yep.
Sorry, what was that?
0.179 for the p value.
0.109.
I got 179.
79. Got it. Okay.
0.179. And then 18. What conclusion do you draw about the mean sodium levels of the 3 types of hot dogs? Use a level significance of 0.05.
It's got to be the second one, right?
Yeah, that's what I'm thinking because we don't have significant evidence to reject the claim. I think so.
Let's do it.
All right, I'll submit. Hold on 1 second. I'll tell you how we do. Make sure I got them all saved here. All right, we got a 95%. I think we only missed one. I just got to find it.
So
So
it's a multiple choice.
question 15 was the one we missed.
That was the
We have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories.
Should I try the first one? We have sufficient evidence, and then Michael can try one of the do nots.
Yeah,
Sure.
Because then we'll automatically get the question right.
right.
So I'll try the first one.
Okay. So Michael, the answers. Let me get this.
Okay, I missed it too, so
Oh, did
it's
you?
something else. Yeah.
All right, Michael.
I'm going to go with B. We don't have sufficient evidence to reject the claim.
Okay. So we got, if you want to start at the top, question 3, I'll tell you what we got on these.
Sure, let's do it.
So true for question 3.
Mhm.
4 is check the bottom 2. So check data in each group are normally distributed and variances are equal in each group.
Right.
Question 5 is the bottom one. Construct a QQ plot.
Okay.
Question 6 is the second one. The largest variance is less than 4 times the smallest.
All right.
7, we got 6. The answer is 6, the number 6.
All right.
8 is 27.208.
27.208.
Yep. 9 is 53.158.
All right.
And question 10 is true. Question 11 is true. Question 12 is 0.309. Or 0.309, sorry.
All right.
13 is right. And then I think you've got everything from there, right?
Yep.
Except for 15, you're going to want to change that
Yeah.
to be.
Yeah. 15, I switched that to B. We do not have sufficient evidence, and we'll see how that goes.
Okay.
Perfect.
1 moment, I'll let you know. No, I missed it. So it's the last one. We have sufficient evidence to claim that at least one.
Well, that was a useful way to get there.
Yep.
Those are the ones that are going to kill me on the test this weekend. Or that kind of thing. Those just get me every time. I have to read them and then I reread them and get different answers every time.
Well, see, the reason that that one is right is because whenever you remember that we know that there's sufficient evidence that one of the hot dog types has a different mean. It's not all of them because the null hypothesis that they're all the same.
Right.
But the alternative hypothesis is that at least one has a different. So I don't know if that helps, but that makes sense now. We just have to read it, like you said. But well, I think I can. I'm gonna head out now. I can probably get the rest, type these in again myself. So
Cool.
thanks for meeting with us, guys.
Yeah, no problem.
All right, we'll see you on Thursday with the review.
Yeah, with the big review.
All right.
All right, have a good one.